Hello students, this is actually my second laptop, the new laptop, so I'm not having proper settings. I don't know, you can see I'm not having that green screen effect. You can see the green screen behind me. So, and that is why I am late as well by 5 minutes. Usually I don't late by 5 minutes. But Well, let's try. Please let me know whether you are being able to hear me properly or not, because with my last laptop that I was using, I was hearing some complaints that the sound was not audible when people were using the mobile phones to listen to my videos. They were not being able to hear the sound. So when they are heard through a laptop, or even it is not that through every mobile phone, whichever mobile phone you are using, you are not being able to hear the audio. The audio was audible. Um, I am having two mobile phones. For one of them, it was totally clear, and for the other, it was not so clear, but it was audible. But yes, but I have seen one of my friend's mobile. uh, in that mobile, it was totally not audible. So I have seen that problem coming up, and I don't know the solution of that. Therefore, I have changed the laptop. Please do let me know whether the audio problem has got resolved or not. Okay. And another thing that I would like to see is uh, we are doing, as you are seeing, that we are solving the IB Math AA SL May 2022 paper 1 time zone 2 section 8 questions. We'll be solving the section 8 questions, that means question 1 to question 6, and we'll be solving the section B questions tomorrow from 5 p.m. IST, and next week, that will be the April 22 and April 23, we will be solving the paper 2 times time zone 2 questions. Section will be questions will be solved. Section A questions will be solved on Saturday, and section B questions will be solved on Sunday. But after that, there is one more examination that has been held. That was on November 2020. So, but I don't have the PDF question paper of November 2022 IB Math ASL or IB Math AHL. I'm not doing the live sessions of HL right now. I'll be doing the HL live sessions after I complete this. But I am not having the IB Math ASL November 2022 paper. If you want me to conduct live sessions on those paper, you are having two papers, paper 1 and paper 2. If you want me to explain the answers to those questions, please send me the PDF format of the question, because I'm not having. Okay? So this is my request. In case you want me to explain the questions to how will they be answered, please do send me the PDF format of the question paper, the paper 1 and paper 2 of November 2020. Okay. So now let us start with our today's session. And how will you be sending? You can send me through my email. Okay, let me just write the email address over here. My email address, and is actually it is there, miss, in my previous laptop. All the things, all the details were visible, miss, but I did not have time to set up this computer properly. nsnillasany@gmail.com. This is my email ID. You may send the 2 papers in my Gmail address. Okay. So we start today with question number 1 of IB Math AA SL May 2022, paper 1, time zone 2. Okay. And question 1 contains 5 marks. And it says the following, and since it is a paper 1, it will be a non-calculated paper. We will not be allowed to use any calculator for getting the answer to the question. So the following table shows values of f of x and g of x for different values of x. Both f and g are one-to-one functions. Okay, and the x values are given -2, 0, 3, and 4. The f of x and the g of x, the corresponding values are given. Like f of -2 is 8. That way we will be reading. F of 0 is 4. G of -2 is -5. That way we will have to read the table. Okay, and we are saying that find g of 0. Find g of 0. So x is equal to 0. X equal to 0 is this column. Therefore, g of 0 is equal to -2. It just contains one. So g of 0 is equal to -2. Okay? Next, it is that was part A. So part B is find f of g of 0. Sorry. This is a composite function. So what is g of 0? We will be working from inside out. So we will be first of all getting g of 0, and we have got the value of g of 0. So f of g of 0 is equal to f of -2, because f g of 0 is equal to -2. F equal to f of -2. And what is f of -2? It is 8. This is equal to 8. Okay. So part C, find the value of x such that f of x equal to 0. If we search this column, this row, we'll see f of x equal to 0 for x equal to 3. So x equal to, this question number 1 contains 5 marks, and you definitely will not be needing 5 minutes to answer these subparts. You have to save, and not only should you be answering, you should be checking as well. Do not leave the checking part, because these are trivial questions. Okay? You may have done some silly mistake. So you should not be doing any silly mistake, especially in these questions. Okay? But anyway, you should make it a habit of checking. And since you may be having difficult questions at the end, difficult with respect to this question, okay? So you should be saving time. If you spend 5 minutes, because the question contains 5 marks, I can spend at least 5 minutes. So let me just look at the question and write slowly. You have to write fast and write correctly. So question number 2, again, maximum mark 5. The nth term of an arithmetic sequence is given by un equal to 15 minus 3n. Subpart A says state the value of the first term u1. So n should be equal to 1, because nth term, the first term is u1. So 1 is equal to 15 minus 3 times 1 is equal to 15 minus 3, which is equal to 2. 12. 15 minus 3 equal to 12. Or I can write U1 equal. Given that the nth term of this sequence is negative 33, find the value of n. Let me put here. Okay, so nth term un is equal to negative 33 equal to the expression 15 minus 10. Okay, we have to get the value of n. Therefore, negative 3n is equal to negative 33, negative 50, which is equal to negative 40. 5 plus 3 is 8, 3 plus 1 is 4, so negative 48. And we can cancel these minus signs on both the sides. That is, cancelling means we are dividing or multiplying both sides by minus 1. We can multiply both sides by minus 1 or we can divide both sides by minus 1. Anyway, the two signs will get nullified. So 3n equal to 48, and then we divide both sides by 3 to get n equal to 48 over 3, which is equal to 60. Okay? So n is equal to 60. Next is subpart C, find the common difference. It is said that these are terms of an arithmetic sequence. So we don't have to prove that this is an arithmetic sequence. They are terms of the arithmetic sequence, so there has to be a common difference. So let us take 1 and U2, or I can take in UN and UN plus 1 up to us, up to you. Okay, let us take U1 and U2 because most of the students will be taking U1 and U2. So we have found U1 most probably, yes. U1 is equal to 12. Let us find U2. And we can subtract to get the common difference. U2 n equal to 2. So this is equal to 15 minus 3 times, which is equal to 15 minus 6 equal to 9. 9 plus 6 is 3. Therefore, common difference D is equal to 9 minus U1 is equal to 12. Let me show you once more. 1 is equal to 12. Or E is equal to negative 3. Okay. We are done. I hope you have completed all the subparts. Yes. Question 3, maximum mark 6. Consider any three consecutive integers. That are consecutive integers. Obviously, they are differing by 1. N minus 1, n and n plus 1. Prove The part A says prove that the sum of these three integers is always divisible by 3. Find sum of the three integers. What is the sum of the three integers? N minus 1 plus n plus n plus 1. This is equal to this minus 1 and plus 1, they will be getting cancelled. So this is equal to 3l, which is divisible by 3. Okay? I am doing 3 questions. Let me change the color. Then I'll 4, 5, 6 done. Prove that the sum of the squares of these three integers is never divisible by 3. Squares of the sum of the squares. Sum of the squares will be n minus 1 square plus n square plus n plus 1 whole equal to n square minus 2 plus 1 plus n plus n plus 2n plus 1. Okay? This is equal to 3n square minus 2n plus 2n will get cancelled plus 2. So I can write this as n square plus 3 minus 1. This is, I can take out 3 from the first two terms and it n square plus 1 minus 1. Now this term is divisible by 3 because it is having a factor of 3. This is a number which is divisible by 3. And the whole thing is a number which is 1 less than the number divisible by 3. So we let 3n square plus 1 be 3k, where k is equal to n square plus 1. Therefore, 3k is divisible by 3. Or 3k is the number which is divisible by 3. Therefore, 3k minus 1 is a number just before is a number just before 3k. Get that? Just before 3k. And we know that, see, if 3 is divisible by 3, of course. So if I take the number 2, which is just before 3. 2 is not divisible by 3. You take any number. 9 is divisible by 3. And the number just before is 8. 8 is not divisible by 3. 3k minus 1 will never be divisible by 3. Sorry, there were two. Question number 4, maximum mark 6. A function f is defined by f of x equal to 2x minus 1 over x plus 1, where x is a real number and x is not equal to negative 1. Okay, and the part A says the graph of y equals f of x has a vertical asymptote and a horizontal asymptote. Definitely write down the equation of the vertical asymptote and the horizontal asymptote. These are I and I contains 2 marks, 1 mark each. So the vertical asymptote, how do we get the equation of the vertical asymptote? By equating the denominator to 0. So it will x plus 1 is equal to 0. Gives us x equal to negative 1. This is the vertical asymptote. The horizontal asymptote is, since the highest power of x in the numerator and the denominator, they are the same. It is power of 1 in the numerator and x to the power of 1 in the denominator. We will be taking the coefficients of these terms. So it will be y equals 2 over 1, because 2 is the coefficient of the term containing x to the power of 1 in the numerator, and 1 is the coefficient of the term containing the power of 1 in the denominator. So y equals 2.2 over 1 or y equals 2 is the horizontal asymptote. Okay. On the set of axes below, sketch the graph of y equals f of x. So let us first of all sketch the horizontal asymptote. Okay. Fine. Y equals 2 is the horizontal asymptote. Let me do. And x equal to negative 1 is the vertical asymptote. X equal to negative 1 is the vertical asymptote. Now let us get the zeros. We have 0. Let us first of all write the function. It is f of x equal to x minus 1 over x plus. Therefore, when x equal to 0, what is the, let us first of all get the y-intercept. Y-intercept will be times 0 is 0, so negative 1 from the numerator, and 0 plus 1 is 1, which is equal to negative 1. So 0 comma negative 1 will be the point on the y-axis. 0 comma negative 1. This is the point. And what about the 0? Where y equal to 0. Since y equal to 0, the numerator has to be equal to 0. 2x minus 1 is equal to 0, or 2x equal to 1. This gives us x equal to 3. So it will be half comma 0 will be the second point. Half comma 0 over here. Comma negative 1 and half comma 0. This is actually 1 is the vertical asymptote, y equals 2 is horizontal asymptote. So now we can test the graph. Will be this way, and so this is the graph. Y equals or f of x. Y equals f of x. So we have done the subpart E, subpart B. Now we call the inequality contains only a single. Call the inequality hence. Hence, because that means we have to use the whatever we have done, the first two subpart, most probably in the subpart B. Solve the inequality 2x minus 1 over x plus 1. This is the expression for f of x is greater than 0 but is less than 2. F of x value, that is the y value, will be between 0 to 2. Which portion am I getting? This portion? This portion of the graph will be taken because it is only the portion, this portion is only the portion which is between 0 and 2. And where is the graph crossing the x-axis? Because it has to be greater than 0. Has to be greater than 0. So where is the graph crossing the x-axis? The graph is crossing the x-axis at this point, which is half comma 0. That means x equal to half. Okay? So the answer will be x is greater than half for all values of x which are the right side of x, this x equal to half. For all values of x which are greater than half, the corresponding y values are between 0 to y equal to 2 is the asymptote, so it will not be crossing that asymptote. A graph crosses a vertical asymptote, may cross a vertical asymptote at small values of x. But over here, we are seeing that the graph did not cross the asymptote, not crossing even when x equal to 6. We can check whether the graph crosses the horizontal asymptote at x equal to 6 or not. What happens? What is the function value when x equal to 6? Let us find. This will be 2 times 6 minus 1 over 6 plus. This is f of 12 minus 1 is equal to 11, and this is plus 1 is 7. So this is 1 and 4 over 7, definitely not more than 8. So even at x equal to 6, the graph is not crossing it is below the y equals to. So the graph doesn't cross the the horizontal asymptote at large values of x, because what is the meaning of the horizontal? The graph will be trying to reach the horizontal asymptote as the x values tend to move to positive infinity or negative. Okay? That is the meaning of the horizontal asymptote. So the function graph will never be crossing the horizontal asymptote for large values of x. Written the answer. This y is greater than, not y, but from the test graph, x is greater than half. Okay? Have completed clearly indicate the asymptotes and the position of intersection of the axis. We have done all those. But see completed. Come to question number 5. Find the least value of x for which cos of x plus 2 plus pi by 3 equal to 1 over root. Let me just write the question. And what is 1 over root 2? It is one of the values, one of the angles, cosine of which angle gives you 1 over root 2. One of the angles is pi over 4. Cos of x over 2 plus pi over 3 can be equal to cos pi over 4, because cos pi over 4 also has the value of 1 over root 2. So let me equate the two angles. So it can be x plus x over 2 plus pi by 3 equal to pi by 4. So pi by 4, x over 2 is equal to pi by 4 minus pi by 3. Or I can have the common denominator as 12. So it will be pi over 12 minus pi over 12. And this is minus pi over 2. So, and obviously x will be equal to negative pi over 6, because after multiplying both sides by 2, we get the x value as negative pi by 6, but they are saying, they are asking for least positive value of x. Okay. Therefore, we have to try some other angle. This pi by 4 will not be working for us. So, in the first revolution, in the first 4 quadrants, in the first revolution, first, second, third, and fourth, cos is positive in the first quadrant and in the fourth quadrant. The first quadrant angle is pi by 4, which we have tested. So let us try the fourth quadrant angle. What is the fourth quadrant angle expression? It is 2 pi minus theta, where theta is the first quadrant angle. So let us try that. So we can write cos x over 2 plus pi by 3 equal to 1 over root, which can be said to be equal to cos of 2 pi minus pi by 4, the angle from the fourth quadrant. And what is 2 pi minus pi by 4? This is cos of 2 pi is 8 pi over 4, which is cos 7 pi over 4. Okay. So now we can equate the angles of both the sides. So it is x over 2 plus pi by 3 equal to 7 pi over 4. Or x over 2 is equal to 7 pi over 4 minus pi over 3. And again, we make the denominator as 12 for both the terms. So first term get multiplied with 3. So it is 21 pi over 12 minus 4 pi over 12. And 21 minus 4 is 17. 17 plus 4 is 21. So it is 17 pi over 12, which is equal to x over 2. So multiplying both the sides by 2, we get x equal to 17 pi over 6. 17 pi over 12 times 2 will be 17 pi over 6. Okay. I can just do the multiplication. I'm multiplying both sides by 2. We are done with the question as well. The last question. Maximum marks 7, question number 6. Is 2 subparts. Consider the binomial expansion x plus 1 raised to the power of 7 equal to dot, dot, dot. If a and b are positive integers and x is not equal to 0, so that b equal to 21. Fine. So let us start part A. So that b equal to 21, first of all, let us expand this. Otherwise, how can we come to be coming to a, b, everything? Let us expand. So x plus 1 raised to the power of 7 is equal to, you remember the binomial theorem? Will be r summation of r equal to 0 to 7, x to the power of 7 minus r, and times sorry, let me write the coefficient first. It is 7CR x to the power of 7 minus R times 1 to the power of R. 1 to the power of anything is 1. So now we just write the terms. For the first term, R is equal to 0 and 7C0 in C0 is 1. So we don't write 1 explicitly. X to the power of 7 minus 0 is x to the power of 7. And 1 to the power of 2 is 1. First term is x to the power of 7. You see, first term is x to the power. What is the second term? 7C1. 7C1 is 7, but anyway, let me show you. Because R equal to 1 for the second term. So it is 7C1, which is 7 factorial over 1 factorial times 7 1 minus 1 factorial. Okay? And x to the power of 7 minus 1, which is 6. I'm not writing 1 to the power of because it is 1. How many terms have they given? 1, 2, 4. Final will be 1 to the power of 7, that is 1 problem, but I have to get 4 terms. The fourth term is given, but we can at least show that we are also getting the same. Fine. So this was the second term. The third term's R value will be equal to 2. So it is 7 factorial over 2 factorial times 7 minus factorial times, these are all multipliers. X to the power of 7 minus 2, that is 5, plus this time R is equal to 3, 7 factorial over 3 factorial times 7 minus 3 factorial times x to the power of 7 minus 3 is 4 plus dot dot dot. Not writing all the terms. And of course, plus dot 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 means it is an infinite series, but it is not an infinite series. So the last term is plus 1. Okay? This term towards the left. Cannot. So now let us expand this or by these. I've already expanded. This is 6 factorial. 7 factorial over 6 factorial will be 7. Because 7 factorial is 7 times 6 factorial. So this is plain and simple. This is 7. 7x to the power of 6. Plus, okay, for this let me write this. Factorial is 2. And this is 5 factorial, which will be getting cancelled. And this is the power of 5 plus this is 7 minus 3 is 4. So 7 times 6 times 5 times factorial. 3 factorial is 3 times 1 times 4 factorial. And 3 times 2 is 6 x to the power of 4 plus dot 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 plus 1. So the power of 7 plus 7 x 6 and this is 7 times 3. The other number has got cancelled. So it is 7 times 3 is 21. The power of 5. That's 7 times 5. These are the only remaining numbers. 7 times 5 is 35. X to the power of 4 is dot 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 plus 1. Okay? Now we relate this expression that we have found with a given expression. Let me bring in this expression. E should be equal to X to the power of 6, and this is 7x to the power of 6. So E is equal to 6. Dx to the power of 5, D is 21 because 21x to the power of 5. 35 this. So the question was most probably show that B is equal to 20. Please show that B is equal to 21. B equal to 21 shown. And then we come to the part B of question. Repeated these 6 questions. Go fast today. The third term in the expansion is the mean of the second term and the fourth term. Okay, let me bring in this question below. Otherwise, let the questions stay in front of our eyes. The third term in the expression, expansion. What is the third term? Third term is 21x to the power of 5. Is the mean of the second term. What is the second term? Seven x to the power of 6. And the fourth term. What is the fourth term? One, two, three, four. 35x to the power of 4. Now they are saying that the third term in the expansion is. Okay, let us just write that. Third term is 21 x to the power of 5. Is means is equal to the mean of. That means the average of So second term is 7x to the power 6. Since we have to take the average of these two numbers, the second term and the fourth term, we have to add them and divide by 2. So it is 7x to the power of 6 plus 35x to the power of 4. And they have said find the possible values of x. That gives us the information that we will be getting values of x, not a single value. This is divided by 2. This is the equation that we have found. So I can take this x to the power of 4 and rather 7x to the power of common from both the terms of the numerator. It is x to the power of plus 5 plus 5 and divided by 2. And so, first of all, we divide both sides by 7. Let us divide both. So this will be 3x to the power of 5, x to the power of 4, x squared plus 5 over 2. Okay? And now we divide both sides by x to the power of 4. Just by looking at these powers 5, 6, 4, oh my goodness, don't have the calculator. We do not know how to solve the question having equation having 4, 5, 6 powers of x. We have never done such equations. We have not solved such equations before. So you start to panic. You don't even realize, you don't see the question that you can cancel. See, you can cancel x to the power of 4 from both the sides. Even though you are seeing these large powers of x, just don't assume that you will not be able to solve the equation. See if you can. Always you have to try. Don't leave question. Don't give up so easily. You try. So you have to divide the entire equation by x to the power of 4. That gives us an equation of this form, 3x equal to x squared plus 5 over 2, or multiplying both sides by 2, we get 6x to x squared plus 5. Now it has become a quadratic equation. Let us add negative 6x to both the sides to get x squared minus 6x plus 5 is equal to 0. So we can write this as x squared minus x minus 5x plus 5 equal to 0, or x minus 1 minus 5 x minus 1 equal to x minus 1 5, which gives us the x values as 1 or x equals 5. X cannot be equal to 0, definitely that we know, because x equal to 0, x plus 1, 0 plus 1, 1 is 1, 1 to the power of 7 will be 1, you will be having 1 to the power of 7 is 1, you won't be having any binomial expansion. So x cannot be equal to 0, and they have said that x is not equal to 0. Therefore, even if you by mistake get x equal to 0, just realize that the actual values of x are x equal to 1 or x equal to 5. This, I think, was the last question and question number 6, and it continues. Some parts, I think the questions were fairly easy for this paper. The 6 questions are definitely easy. Let us see how are the questions section solving them too. Okay. So students, thank you for staying with me till the end. If you have any doubts, any queries, please feel free to write to me in the comment area. I'll be trying to help you as much as I can. And again, I'm saying before ending this session, in case you want me to solve the questions of November 2022, paper 1, and please do send me the question papers, the 2 question papers in PDF format. And again, let me, before ending the session, let me just give you the email ID, which you are not being able to see in the session. My email ID is So we meet again tomorrow at 5 p.m. IST to solve the section B questions of IB Math AA SL May 22, paper 1, time zone 2. Okay? So till then, bye.